Do we now have a chance of detecting the universe's elusive dark matter? An attempt to find dark matter underground is taking place as we speak here in Australia, where scientists are hopeful they could make progress before Christmas. It takes half an hour to journey underground to the site of the Southern Hemisphere's first dark matter underground lab. It's a 10 kilometers drive down a maze of tunnels to the cavernous laboratory, 1,100 meters underground, where work is ongoing on dark matter experiments with equipment designed to find the elusive matter. This thing, called dark matter, makes up 85% of our universe, yet it continues to be a mystery. Starwell's gold mine in regional Victoria, the second smallest state in Australia, has become the place to locate dark matter. The 33 meters long, 10 meters wide lab will have the world's largest and most sophisticated detectors of dark matter. Experiments on an even larger scale are also taking place in the US and Italy. Watch this video to find out how scientists are tracking the elusive material that holds the galaxies together. Meanwhile, I've left you some more materials in the description below. Please make sure you read them. I'm Majed Tayfor, your personal life coach, but you can call me Michael. Email me at michael@coachacademy.com to find out more about my bespoke life coaching technique, also known as transcendental re-engineering.
Deep underground, scientists hope to close in on one of the most elusive targets of modern science: dark matter. In subterranean laboratories in the US, Australia and Italy, they have set up huge vats of liquid xenon and lined them with highly sensitive detectors in the hope of spotting subatomic collisions that will reveal the presence of this elusive material. The findings of their research will reshape our understanding of the cosmos. Dark matter accounts for around 85% of all the universe's mass, but we have not been able to detect it so far, despite building more and more powerful detectors. The hunt for dark matter began last century when astronomers found that galaxies appeared to be rotating too quickly to remain stable. Observations indicated they must have masses 10 times greater than their visible contents, stars, planets and dust clouds, otherwise they would tear themselves apart. The missing material generating the extra gravity needed to hold galaxies together was dubbed dark matter. Astronomers initially thought it could be made up of stars too small or dim to be seen from Earth or by other candidates, such as neutron stars. However, new generations of powerful telescopes showed these were not viable possibilities. So scientists turned from the astronomically large to the incredibly small to explain the universe's missing mass. Vast numbers of undetected particles form invisible halos around galaxies and boost their gravitational fields. These hypothetical particles are called WIMPs, weakly interacting massive particles, and for 2 decades researchers have strived to detect them.
Create the life that you love. Get yourself a life coach. Email me at michael@coachacademy.com.
These efforts have involved building detectors deep underground, where they are shielded from subatomic particles, triggered by cosmic rays hitting the upper atmosphere that constantly shower down on Earth, and which would trigger streams of false positive readings on their instruments. The expectation has been that a WIMP will strike a xenon nucleus and the resulting flash of light will be spotted by a detector and so reveal the presence of a dark matter WIMP. Despite years of effort, we have yet to see a single flash like that. Now researchers are pinning their hopes on the two most sensitive WIMP hunters ever designed. One, built below Italy's Gran Sasso Mountains. The other has been constructed in an old South Dakota gold mine. Both devices have been filled with several tons of xenon, much more than has been put in any previous device, and that should increase chances of a nucleus being struck by a WIMP. A third attempt is being made deep inside Starwell's gold mine in regional Victoria, the second smallest state in Australia, which has become the third place to locate dark matter.
Be your own best version. Get yourself a life coach. Email me at michael@coachacademy.com.
If the devices fail, scientists will have one final chance to use current technology to find them, by joining forces to create one final super-large detector that would contain tens of tons of xenon, a rare and expensive gas to isolate, and which would be run for several years. And if that last chance detector fails to find dark matter, scientists would be stumped. It could be that in looking for dark matter, scientists would be looking for keys under a street lamp. Dark matter could be a lot weirder than anyone may have assumed so far. It could be made of tiny black holes. Or it could be made of something that's 1,000,000 times lighter than a WIMP and detecting that will be very hard. Yet, if it were not for dark matter's pervasive gravitational influence, galaxies and stars and planets would not have held together in the early universe, and life as we know it would not have evolved. Hence scientists' continuing efforts to discover its true nature. And by discovering its true nature, they might stumble on the darkest secrets of our universe.
How are you feeling? I'm here to help. Get yourself a life coach. Email me at michael@coachacademy.com.
The universe is riddled with secrets. What was the cause of the Big Bang? Is there anything that came before it? What makes the human cell so complicated? What happens to our awareness once we pass away? What happens to the stuff that a black hole absorbs? Last but not least, many scientists are unsure what dark matter is and how it came to be. Astrophysicists have long been perplexed by the enigmatic type of matter. Dark matter, in other words, is considerably more uncommon than the ordinary matter with which we interact every day, hour, minute, and second. Dark matter is the missing material that produces the additional gravity needed to keep galaxies together. It was first assumed to be made up of stars too tiny or dim to be seen from Earth or other candidates like neutron stars. Newer generations of powerful telescopes, on the other hand, demonstrated that they were not realistic options. To explain the missing mass of the cosmos, scientists ranged from astronomically huge to highly tiny. They claimed that large quantities of undiscovered particles from unseen halos surrounding galaxies boost their gravitational forces. Weaklings are massive particles that interact weakly, and researchers have discovered them for the past 2 decades. These attempts have entailed the construction of detectors deep below, protected from subatomic particles, which are activated by cosmic rays striking Earth's upper atmosphere, causing streams of false positive signals on their sensors. Researchers are now placing their faith in these detectors. However, it is now widely acknowledged that this may not occur and that dark matter may remain mysterious. I hope you enjoyed watching this video. Email me at michael@coachacademy.com for more information on my transcendental re-engineering life coaching technique. I offer both life mentoring to those who need it in these difficult pandemic times, and strategizing for businesses that are suffering due to continuous lockdowns. Be safe and stay home. Your well-being is what matters the most. I've left you all the instructions you need in the description below. Use them wisely. Bye for now.